duty algebra today. So let's give you a quick recap on some of the things we've covered and some of the things we have still to cover. Last time, we looked at the beginnings of rational expressions. So let's just remind you the different kinds of factoring that you do. Sometimes, as in this example, you do common factor. In this case, the common factor is 2x squared, and this is what's left. We looked at difference of two squares. Here's an example of it. And we looked at what I'm calling simple quadratics. A simple quadratic, also called a simple trinomial, has an x squared, right? 1x squared, not 2x squared or 5x squared, just 1x squared. So if it starts with an x squared, it's a simple one. And here are 4 examples of it. The technique for factoring these types of quadratics are you look for 2 numbers that multiply together that give you this guy, plus 10. And those same 2 numbers, when you add them together, give you plus 7. So you can see here, 2 and 5 add up to 7, and 2 times 5 gets you 10. In this case, -3 times 5 gets you -15, but -3 add 5 gets you plus 2. And this one works, and this one works. And that's kind of where we left off. Now, there are a number, really 2 more techniques that we need to be aware of. So that's going to be my number 4. And later on, we're going to do another one called number 5. But let's do number 4. And once I've done that, we're going to start looking at simplifying fraction expressions, which we call rational expressions. So we're going to simplify them. And the technique's going to be pretty much involving factoring and then cancelling. So let's look at an example of how you do these guys. These are going to be complex quadratics. But these are ones that have a common factor. So show you an example of that. I'll get this out of the way, it's a little distracting. Let's show you how the one that I had written down there works. So you've got 4x squared, you've got an 8x, and you've got to take away 32. Now, the count is complex because it's got 4 here, right? It's not 1x squared that's got 4. But if you look really carefully, do you notice that there's a common factor of 4 that you can pull out? So if you pull out a common factor of 4, you get an x squared left over, a plus 2x left over, and a -8. Now, if you forget about the 4 for a minute, isn't that just a normal simple quadratic, right? And so we'll factor that the usual way. So what does that mean? It means I'm going to be looking for 2 numbers that multiply together that give me -8. But when I add those 2 numbers together, I get plus 2. So I know there's going to be an x here and an x here. And I need 2 numbers that multiply together, give me -8, sorry, and add together and give me 2. Anybody got the combination that works? Because there's only one that works.
It's 4 and -2.
Okay, so we're looking at plus 4 and a -2. And check out, he's right. You see, multiply -8, add them together. Now, if you foiled that whole thing out and then times it by 4, you should always get back to the original. And this is, we're done, right? This is the question finished with. Okay, so let's look at another one. Suppose we have, oh, let's change the letter. 3b squared plus 9b, take away 12. And let's suppose we need to factor this quadratic. It's always a good idea to look in these complex ones if there is a common factor, because if there is one, it's going to make your life 10 times easier. Can you see any common factor in this question?
3.
Yeah. It's almost always going to be this leading coefficient, right? The guy next to b squared. So that leaves me with a b squared plus a 3b, take away a 4. So we need two numbers that multiply together that give me -4. And when I add these numbers together, I get +3. Any candidates that do that job? Two numbers that give you -4 when you multiply them, but when you add the two numbers, you get +3.
4 and -1.
And we're finished. Do you feel comfortable about this technique, or do you want to see another one? Feel good? Okay. Then that kind of takes care of, right now, that takes care of any kind of factoring that involves these 4 things we should be able to do. Now, there's still one more guy coming, which is this guy, but I'm not going to go near him yet because he is going to be a kind of major job, right? He's going to be probably harder than all the other methods put together, right? So I'm not going to worry too much about doing that right now. What we're going to do now is start looking at our homework questions. And we're going to look at, this is homework 6, by the way. Which is how to simplify rational expressions. So let's, basically this is the shopping list. This is what you normally do to simplify any rational expression. Step 1, factor the top and the bottom, which is why we've been spending so long getting good at factoring, right? So factor the top, factor the bottom. Step 2, cancel any common factor. Now, by that I mean, if there's a guy on the top and there's another guy on the bottom and they're the same, you can cancel with a 1-for-1 deal. And then you do, what you do lastly is just write down what's left, and typically that's the end of the question. So let's start with a version of question 1. And it doesn't actually need step 1. This fraction is going to get simplified. And what we're going to do is move right on to step 2 and do cancelling. So let's see what we've got. If you take the number 6 and the number 3, you can simplify those down, right? And can't you divide 6 and 3 and 9 by 3? So you divide that by 3 to get 2, and you divide this guy by 3 to get 3. So that's that one done. Now, do you notice that there's an x squared on the top and there's an x on the bottom? You see these two guys here? X squared and x. You can cancel. But what I mean by a 1-for-1 deal is one of these x's cancels out only one of them. So if there's an x squared on the top and an x on the bottom, would you agree that you're still going to be left with one x left over? That makes sense? Now, I'm running short of colours, so I guess I'm back to going red again. We have a y on the top and we have a y4 on the bottom. So we can cancel, right? But it's a 1-for-1 deal. So what's going to be left on the bottom in this question?
Y3.
Right, y cubed, y3. And that's basically step 2 done. Now, step 3 just says, write down what's left. So let's see what's left. A 2, an x, and everything else is gone. A 3, that's gone, and a y cubed. And so the original fraction has now been simplified down to that much nicer, prettier, smaller fraction. It's a little bit like taking 4/8 and calling it a half, right? It's a lot more complicated than that, but isn't it essentially the same kind of idea? You take a fraction like 4/8 and you write it down in a simpler version of itself, right? In this case, that ugly fraction can be simplified down to this one. Do another one. Okay, let's do 4 b squared c d cubed over 8 b squared, c cubed, d to the 4. Now, basically start at the left and work my way along. Would you agree that the 4 and 8 cancel? Right? Numbers cancel a little bit differently than the rest, but doesn't 4 on the top and 8 and cancel. If you divide that by 4 and that by 4, do you see you get a half? Okay. Now, I haven't seen this yet, but it does happen sometimes. I have a b squared on the top, and it's going to cancel out a b squared on the bottom. Don't they basically kill each other off and there's nothing left? So we're good. I have a c on the top and a c cubed on the bottom. Okay. 1 for 1 cancel. What's left and where does it go? So if you've got a c on the top and a c cubed at the bottom and you cancel them out, what's left and where does it go? Does it go in the top or the bottom? What's left?
Bottom.
And what's left?
The c squared.
You all happy with that? Now, if we go to the last one, we have a d cubed on the top and a d to the 4 on the bottom, right? So they're going to cancel. And you basically say, okay, 1 for 1, 2 for 2, 3 for 3, right? You're going to cancel, right? A 1 for 1 deal. What's left and where's it going to go?
D on the bottom.
Agreed. Now, if you scan through the top, the only thing that's left was a 1, right? Used up, used up, used up, right? Nothing left out there. On the bottom, there was a 2, used up, a c squared, and a d. Would you agree that that's a much prettier looking fraction than the original fraction before I put all the crosses through it, right? And so that's why we call it simplified, right? It's simpler looking, it's nicer looking. Okay. Let's give you one. I always think if I give you a question and you know how to do it, then that's kind of evidence that you're good to go, right? So let's put the x's and y's back in. So x cubed y to the 5 over 20 x y to the 7. Okay. You've got 1 minute to try that one out yourself, and then I'll do it. Okay, here goes. 12 on the top, 20 on the bottom. What's the biggest number that you know that divides a 12 and a 20?
Yeah. 4.
I agree. So you get 3 on the top and 5 on the bottom. Did you all get that? 3/5, I hope. Do you know if you got 6/10, couldn't you do a second shot and cancel 6/10 down to 3/5? So sometimes you don't do it in one go, you need to do it in 2, and that's fine. Okay. X cubed and an x. What's left and where does it go?
2x on the top.
Yeah.
Agreed. Agreed. Y5, Y7. what's left and where does it go?
Y squared on the bottom.
Now I kind of like the fact I'm using red pens here, because when you come to the end, don't you just write down what the red bits say? So I don't think that's particularly helpful, you know, maybe, well, I guess you could do red pen as well. So what have I got? I have a 3, I have an x squared, and that's used up. I have a 5, that was used up, and I have a y squared. So hopefully you ended up saying that. Does that look good? So here are some examples where you didn't need to factor anything because, you know, when it's written that way, I guess it's already factored, but you do have to cancel and then write down what's left. Can we move on? Are we good at this? Anybody want to see another one, or are we good?
Good.
We're good, thank you. Okay, now let's show you some that need step 1. X squared take away 4x over 3 lots of x take away 12. Now, what you don't do here is you don't say, oh yeah, I know how you do it. You cancel these guys out, you cancel these guys out, and what's left is the answer. That's not how it works. The reason we could do that, cancel, you know, what's left and write it down, is that each one of these 3 terms on the top and the bottom, they're all multiplied together, right? And when things are multiplied together, the individual pieces are called factors. So there's like 3 factors on the top and 3 factors on the bottom. Do you notice that the top guys are not multiplied? These are 2 things being subtracted, right? And these bottom ones are 2 things being subtracted. They are not factored, so we got to factor them first before we start saying top guy killing off bottom guy. Okay. X squared take away 4x. Do you see a common factor there? Because that's the way you're going to do this one. What common factor do they 2 things share?
X.
Agreed. Now, if you pull out the x, you're going to be left with an x minus 4. Right? Okay, let's look at the bottom. 3x take away 12. That is also a common factor. So what common factor number do these 2 things share?
I do.
3.
I heard a 3, but I'm not sure if the person who was trying to say it was also going to say the same. Are you happy about if you pull out a common factor of 3, you're left with an x minus 4? Now, I don't care what is on the top. What do I mean by that? I don't care if it's a number. I don't care if it's x squared or x cubed or it's y on its own. I also don't care that it's x minus 4. I can still cancel it. And I can cancel it as a 1 for 1. So can this guy cancel out that guy? It's a 1 for 1 cancel. And what's left is our answer. That ugly fraction is actually the same thing as this much nicer looking fraction. Do you agree we've simplified it? It looks pretty. Looks nice. Are we good? So let's look at, I don't know about this one. This one is like question 8. 4xy take away 3y. And it's 12 take away 16x. Okay, use pens to cover things up. There we go. Look at the numerator right at the top. Can you see a common factor? Because that's what's going on here.
Y.
Agreed. And if you pull out a y, do you see that you get 4x take away 3 left over? You happy about that? Right, now let's look at the other side. can you see a number that's a common factor in this guy?
2.
2 works, but I can think of bigger.
3.
Yeah, 4.
4, yeah, got it, 4. And if you take out 4 lots of 3, take away 4x. And now we have reached, I didn't think it was going to happen here, but since it is, I'm going to tell you that you are allowed to do something here that might seem at first sight weird. 4x take away 3 and 3 take away 4x are not the same thing, right? It's a bit like 7 take away 2 and 2 take away 7, right? They're a different order. But you're still allowed to cancel them. But if you do cancel them, something extra gets added to the answer. And I'll show you in a
1.
minute. Almost. Yes, it's 1, but something else.
Oh, isn't it I was about to say a Y.
It's -1. So if you cancel a 4x minus 3 and a 3 minus 4x, you are allowed to cancel them. But will you make sure your answer's negative when you do that? Now I'm going to prove it to you why that's allowed. Okay? So I'm now about to prove why I can cancel these and still, you know, I'm allowed to do it and where that negative is coming from. So here goes. 4x take away 3. 3 take away 4x, right? I am going to take out a really weird common factor that isn't obvious, but I'm going to do it. I'm going to take out -1 as a common factor. Now, to get -1, this guy will have to be -4x and this one will have to be 3. And let's see if that works. -1 times -4 gets me 4x, and -1 times +3 gets me that. Are you okay with this weird common factor that I've just pulled out? Right. I've pulled out a -1 as a common factor. Now look at this guy. Can't you just switch the order? Isn't -4x add 3 the same thing as 3 take away 4x, right? That's allowed. I'm not doing anything clever. I'm just rewriting the order. Now, I can cancel these. And do you see the negative that I was talking about that's left behind? Okay. So I'm going to give you a little rule here. So you just follow the rule. And the rule says, if you have an A minus B over a B minus A, you can cancel them. But the answer is going to be negative. Okay, so if you have a 5 minus x and an x minus 5, you're allowed to cancel them, right? But when you do it, make sure your answer is negative. So if the answer was 4 over x, make sure it's -4 of x because of this little rule. Will that help if you just say it's a rule I remember to do? But the proof of it is here. Right, let me see if I can find another one of those guys. You know, you can never find one when you want one. Oh, there was one heading up here. I don't even need to factor that question. Isn't that A take away B, B take away A kind of looked at? Can't I do a cancel? What's left behind when you do that?
-1.
And so that guy is -1. You can get much simpler than that. Okay. Let's pretend I've got some. Suppose I had 3x squared, x minus 2, right? So I factored and I got that. And let's suppose in the bottom, I had 6x cubed, 2 minus x, right? Let's suppose I got that, right? So I've got a question and I have factored it. Let's see what we get next. 6 and 3. Well, you can divide them by 3 and you get that guy. Okay. X squared and x cubed, right? They cancel out, don't they? What's left and where does it go?
X on the bottom.
Okay. Now, the special rule, you do it because I told you, right? Can you cancel x take away 2 and 2 minus x? And if you cancel, what does my rule say you should get?
-1.
-1. So there you go. I'll just stick the negative up here. The top row is -1 and the bottom row is -2x. Do you see how that simplified out?
So if we go to the online assessment, we have to put the negative on top instead of in the middle between the fraction.
Oh, have you found that out for us, Jamie Lynn?
No, I'm just wondering if you knew, just in case.
I
before we-
didn't know.
Okay,
So
we'll figure it out.
if I'm picking, if I'm, if that's the answer, what I heard you say is that, do you do that
Yeah,
or do you do that? Is that what you're saying?
yeah.
As far as I'm concerned, they're both equally correct. Now, I hope WebAssign doesn't care and either answer will work, right? Have any of you got the thing in front of you and pick a question where that happened and just figure out where the negative goes? And then I can tell you all, yeah, you have to do it this way or it doesn't matter.
I
Does
think
anybody-
I've made a negative fraction before. I think I've done it before and I think it just made it all negative.
So you stick the negative here and then the fraction after it?
I think so.
Okay, that's as good a rule as any, right? Just stick the negative at the side, right, and then just write the fraction. And if WebAssign goes weird on you, I guess your backup plan is to write this, right? Just in case.
It does the first one.
Yeah, I would do the first one.
That's what it accepts.
Oh, there we go. Have you tried writing that one, just in case it takes it?
I don't recall. It's just all the ones I kept running into problems, and then so I put the negative in front of the entire.
Thingy Bob.
Yeah.
Okay. Well, we know it accepts this version, so I guess that's all you need to know, right? So you do the negative and then the fraction answer. Where am I going with the next one? Ah, a version of question 9. We have x squared plus 4x plus 4. And we have an x squared, take away 6x, take away 16. Now, this is the first one today that we've done where you have a trinomial, right? A quadratic on the top and a quadratic on the bottom. If it's quadratics like this, then it's not pulling out a common factor, right? It's, it's factoring a quadratic. Now, they both begin with x squared. That's good news. So let's just cover up that one and focus on factoring the top. So I'm looking for two numbers that multiply together that give me 4. But when I add these two numbers together, I also get 4. Yeah, I know the numbers. What works? What does that?
2 and 2.
2 and 2.
Agreed.
2 and 2.
Everybody's agreeing with me. Great. Right, let's look at the bottom choices. It's got an x squared, so I know I can do the x thing. Okay, maybe a little bit harder because there's more combinations here, but I need two numbers that multiply together that give me -18, -16, sorry. But when you add those same two numbers, you get -6. Okay, I got one. Give me the combination. I think I've got it.
8 and 2.
Agreed. Which one of these is going to be the plus and which one of those is the negative?
-8. Or the 8's the negative.
Yeah. Now, that is the factor of the bottom guy. This is the factor of the top. So that's what I mean in step one, right? Factor the top, factor the bottom. Can you see why we needed to practice on doing this? Because if we weren't very good at this, this question would be a pain, wouldn't it? Because you'd be fighting every one of them. So hopefully we're a bit faster now at factoring. Is there a guy on the top and a guy on the bottom that can cancel? Well, I would say yes. Would you agree that this x plus 2 cancels with that x plus 2? Right, a 1-for-1 deal. And we are finished. Because all you do then is write down what's left. And some people have a tendency to want to keep going. Don't. That's you finished. So don't say, maybe I could cancel that x and that x, or maybe I could cancel that 2. Don't. It doesn't work. They're not factors. That's you finished. End of story. You got it. So this is a version of question 10 coming up now. Top guy. Bottom guy. Do you recognize what kind of factoring you need for 9 minus y squared? Because we did it on Monday. Do you recognize this guy? Even if you don't remember his name. Well, maybe you do. Does anybody remember the name we give to that?
I do. It's the difference of squares.
That's the one, right? So you're going to go and factor it, right? And when it's a difference of 2 squares, like it is here, or a difference of squares, it's another name for it. How does it factor? Because there's a rule for how you do it.
Y plus 3.
Look
Oh,
at the
wait.
order. 3 first, right? So 3, right? What comes next?
Minus y
Okay, and then 3.
plus y.
Yeah. Now you notice it's not y plus 3, y minus 3. That would be for y squared minus 9. So whoever goes first, and whoever comes second, goes second. You see, the order is important, right? Now, this guy here is our classic, simple quadratic. So 2 numbers that multiply together give me negative 18. But when I add them, I get negative 3, okay? So 2 numbers multiplied together give you negative 18, but when you add them, you get negative 3.
6 and 3.
I like the 6 and 3. Could you tell me which one's the plus one and which one's the negative?
Negative 6.
And obviously the plus 3. Now, do you know 3 plus y and y plus 3 are just the same thing? It's like 2 add 1 and 1 add 2. It is not cancel them out and leave behind a negative 1, right? That's just cancel them out. You okay with that? That y plus 3 is exactly the same thing as 3 plus y, so you just cancel them. Now, if it had been 3 take away y, y take away 3, right? Wouldn't we cancel them out, but remember to make the answer negative, right? So that's what happens there. Now, what's left? That guy on top and that guy on bottom. How are we doing so far? You okay? Right. You know that pretty much all today, at least 3/4 of the work isn't it going to be factoring things? You know, the cancelling's a bit quicker. Most of your time is going to be factoring things.
Wait, can you rewind real quick? Why is this
Sure.
not negative 1?
Why is this not negative 1? Is that the question?
Yes.
Okay. 3 plus y over y plus 3 is going to cancel, but it's just going to cancel and leave behind 1. And the reason for that is that I can rewrite that guy as that guy. It's the same thing. So basically, don't I just have the same guy top and bottom? And when it's the same guy top and bottom, don't you just leave behind a 1? Now that's not the same as this guy. You are allowed to cancel these, right? But when you cancel these, don't you remember to leave behind a negative?
So only if they're both negative.
Correct. If
Okay.
it's something, take away something, you're going to be looking at a negative, right?
Okay.
But if it's something, add something, you know, you're fine. They're going to cancel out without any added stuff. Again, you know. Oh, here is a version of question 12. And I don't need to factor it. I just need to figure out what we get. Okay. Yeah, I'll start at the side. 3 minus x top and bottom, aren't they cancelling out? Right. If it's exactly the same thing in the top and the bottom, don't you just cancel out and get a 1? Okay. What about an x squared on the top and an x on the bottom, right? If you look at those guys, they cancel, but don't you have an x left over on the top? And what about 15 and 18? Well, if I want to cancel numbers, it's find the biggest number that divides both. And I can divide this guy by 3 and this guy by 3. And so what I'm left with is 5x and 1, which is 5x, and 6 on the bottom. And that would be my answer. I just noticed something. Right, here are a number of fractional combinations that could happen. And I want us to be clear that we know what we get in each case, because you are allowed to cancel. I don't think anybody will have a trouble with this one. Would you agree it's a 1-for-1 cancel and you get 1 left behind, right? If you have an x minus 3 on the top and an x minus 3 on the bottom, they cancel and you get a 1 left behind. If the guy in the top is the same thing as the guy in the bottom, they cancel out and leave behind 1. Now, what about a 3 plus x and an x plus 3? Well, don't they also cancel out and get you a 1? Have you noticed the only one of this combination that's the weird one is 3 take away x in the top and x take away 3 in the bottom? And that's the one that leaves behind a negative 1. Are we comfortable in our brain about what is the weird combination, right? So what's the only one that when you cancel it, the answer is negative? So do you see in this question up here, the 3 minus x cancels the 3 minus x, but they're the same thing, exactly the same thing, right? So when they cancel, you get a 1 left behind. Okay, let me pause for a minute. Any questions? Are we still good? Okay, let's keep going then. Version of 13. 8x cubed, 7 take away 4x, 10x, 4x take away 7. Start at the left. 8 on the top, 10 on the bottom, right? What's the biggest number that can divide 8 and 10? What's the biggest number that divides 8 and 10?
2.
2.
Yeah. So you get 4 and 5, right? Okay. I'm going to go through this. Would you agree an x cubed on the top can cancel out an x? But when you do that, isn't there going to be an x squared on the top? Okay, now things get sneaky. 7 take away 4x, 4x take away 7. You are allowed to cancel them. Is this the weird case where -1 is left behind? I see some nods, that's good. Isn't 7 take away 4x and 4x take away 7? Do you see how they switch places? When they switch places like that, that leaves behind a negative. So what do I have? I have -4x squared on the top and 5 on the bottom. I'll leave it for a moment, it'll be good. I'm going to give you 2 questions for you to practice on. So we're back to simple quadratics. Okay. You've got 90 seconds, go for it. Okay, we'll start on the top one and maybe hopefully you'll have time to finish the bottom one. I need a volunteer. Tell me what the top one, this one here, factors
got
out as.
X plus 1 and X plus 6, and then X plus
Oh,
2.
hold. Let's check your 1 and 6 for a minute.
Okay.
+1 and +6 work for that, but does +1 and +6 get you 5?
No.
Okay, so we can fix it. Fix it. What different combination gets you 6 but adds up to 5? One times 6
2 and
doesn't.
3.
That's the guy. 2 and 3. Okay. Someday a volunteer for the bottom. What's going to work here? 2 numbers that give you 8, but when you add them, you get 6. Eight and 1 doesn't work because they add up to 9. So
4 and 2.
4 and 2, all positives. Now, can you see the 1 for 1 cancel? And there's your answer. I'll put it in red. So if you did the top one correct, that's your answer. Okay, I'll take a volunteer. Ooh, that's sneaky. Yeah, I got answer. What 2 numbers multiply together give you -9, but when you add them, you get +8.
-1 and +9.
You got it. You nailed it. What about the bottom?
+4, -1.
And isn't the good news. Cancel, cancel. And what you're left with is an a plus 9 on the top and an a plus 4 on the bottom. And that's the end of the question, right? Don't do any more, it's finished. Looking good? Ooh, oh God. Ooh. I don't like the next one. Well, I do like it, but I don't think you're going to like it. This is a version of question 17. Do you like the look of that fraction?
Is that a 21 or 24?
This is question 17. Is that 21 or 24? Oh, that, sorry about my writing. That's a 4. That's a 24. In my question, you might have 21 if you were looking at your version. We have to factor the heck out of this thing. Whew. And it doesn't look very pretty, does it? Does not look pretty. Okay. Let's cover that up so it doesn't distract us. Okay, what do you think you're going to do to the numerator, the top here? How are we going to factor it?
Factor out a 3x.
I like your thinking. What made you think of that? Because that's the right answer. Was there any clues in that expression that made you say, yeah, it's a common factor rather than something else?
Just both can be factored by 3 and both have an x.
Right. So I guess you've reached the point now where your brain just tells you, right? You can't put it into words, but you kind of know. If that had 3 terms, wouldn't it be a quadratic or something, and we'd have a different technique, right? Or if it was like x squared minus 25, it would be a difference of 2 squares. Don't the other 2 techniques tend to look a little bit different than this one, right? But that's something you're just identifying without even putting words into it. So I'm going to take out, like you said, and that leaves me with x squared, and I believe that leaves me with -4. That's fine. Okay, let's look at the bottom. Any suggestions for what you could do to the bottom? Because that's pretty unique. I don't think we've seen one like this yet. What would you do to the bottom?
You can also do the x squared, not x, 6 squared. Or
Yeah, 6 squared.
6x.
Yeah, I kind of
6x.
knew what you were trying to say. I got it. I got it. So you're going to pull out a common factor of 6x, and that's going to leave me with an x squared, a -4x, and a +4. Okay. So far, so good. Now, this is the first time this has ever happened. We have factored it, but do you notice that x squared minus 4 can be factored even more? And do you notice that this expression here, this quadratic, can it also be factored a little bit more? So let's keep factoring. Okay, let's look at the top. Would you agree that x squared minus 4 is a difference of 2 squares, and that means I can factor it a little bit more? And since it is a difference of 2 squares, x add 2, x take away 2 is what you would get. Are you happy about what I just did there and where it came from? Right. The x squared minus 4 can be factored as a difference of 2 squares, right? You might say x minus 2x plus 2. That's fine. It's the same thing. Right, let's try the other side. Well, we've got 6x already. Do you recognize that quadratic? Right, that can be factored. What we're looking for here are two numbers that multiply together that give me +4. But when I add these two numbers together, I get -4. And it is possible. So don't be negative about this. That was a clue.
You can still add both negatives to it.
Yeah. Doesn't that work? Isn't -2 times another -2 +4? And isn't -2 added to another -2 -4? Do you see it works? It's a little unusual combination, but it works. So what we've successfully done in this question is we factored it a little bit and then factored it a little bit more. And now that we've got this guy, can't we start doing the carnage? This will cancel by that, and let's see what we get. Okay, 3 on the top, 6 on the bottom. Would you agree you can divide both of them by 3 and get a half? Would you agree an X just kills off an X and nothing's left behind? Would you agree that this X minus 2 cancels out that X minus 2, right? A 1-for-1 deal. And that's it. There's nothing left that we can do. So let's see what we get. One of these. Well, we don't normally write 1 in that case then. And on the bottom, 2 lots of them. That was a bit of a challenge question. Wasn't there a lot in there that you could have kind of get caught up in the weeds? But my brain is thinking, factor the heck out of it, right? Factor it until I can't figure anything else that can be factored, which kind of got me to here. And then it's cancel, 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 and write down what's left. Are we good? Try this one. I'll let you try this one. It's a version of 18. Okay, you got a minute. Simplify that fraction. Okay, here goes. What kind of situation do we have in the top here?
Difference of 2 squares.
Okay, and I hope you went x plus 3, x minus 3. Okay, how are we going to tackle the bottom? Going to tackle that?
Factor out a 5.
5x.
Right, is it a 5 or a 5x? What can we factor out?
5x.
Great. And if you do that, you leave behind an x and a 3. So you pause a little while and you say, yep, I factored that as much as I can figure out how to factor it. So I'm done with that. I can now say 1 for 1 cancel. We got our answer. And we're getting more confident with these. See, the more you do, the better you get. Have you noticed that you start just getting into a mindset that you kind of know, okay, I got to factor this, I got to factor that, and then, you know, hopefully the combinations come to you quicker and quicker the more you do. That's what I'm hoping. You can tell me I'm totally wrong, but I hope that's the case. No, done that one. I'm just randomly jumping around to see kind of what strikes my eye. Okay. Would you agree the top is the difference of 2 squares again? But number plus y, the number take away y. You notice it's 2 plus y and 2 minus y, not the other way around. Would you agree that this guy here is a standard quadratic? So 2 numbers that multiply together give me -14, but when I add those numbers, I get -5. So who are the 2 guys that make that happen? Multiply -14, add them together, -5.
7 and 2.
Great. Which one of these is going to get the plus and which one of these is the minus?
-7
And +2, right?
+6.
Yeah. Look really carefully. Can we cancel?
The 2y and then the y plus 2.
Agreed. Aren't they just the same thing written in different orders, so I don't get any -1 left over? Don't they just cancel and that's it? Right? You leave behind a 1, I guess, if you want to call it that. So we are finished with the 2 minus y over y minus 7. Okay, we're getting quite close to having done a fair amount of damage. There's one last factoring thing that I have to show you now. So let me get all this out of the way. Let's kind of go back to the beginning of today. Haven't we done a common factor quite a few times? So you've seen that happen. Haven't we done the difference of 2 squares quite a lot? And we've done an awful lot of quadratics. Haven't we done some where you had to pull out a common factor, right? And then it's a quadratic. So we've seen this being used in a lot of questions today, right? This techniques. What we haven't done is this guy. We are going to be looking at, oops, that's the wrong one, I apologize. This one. We haven't seen complex fractions where there's more than an x squared at the front. Not only is there more than an x squared at the front, you cannot pull out a common factor. Of all the kinds of things that you are going to factor, these are the stinkers. These are the ones that people have a lot of trouble, right? And I can tell you right now, I could give these kind of questions to my, have I got right now? I've got a Calc 1 class, and a lot of them would still have trouble factoring these kind of things. But you need to be able to factor things, right? That's just part of the deal, right? It's part of the math skill set that you have to bring. Now I've got the answers here, which is nice, I guess, but what I'm going to try and show you is how to do these kinds of questions. And we're going to use a technique called the magic cross method. Now, let me pause for a minute and hopefully stop. Who knows what's going to happen here? Because whenever I hit buttons, I tend to break the darn thing. Yeah, that's not the one I want. This one? Yep. Okay, I know you're hiding in here somewhere. Which one have I not touched? This one? Yay, finally found it. Okay, if you just bear with me for a few more moments. Okay. Math 99. That's that done. Good. Into student view. Perfect. Okay. What I was doing there was getting into Canvas. I want to show you. Because what I'm about to do, this method I'm about to do, there is a video on it that you may want to have a look at, because you know, the more people that show you the trick, the better it's going to be. So if you click on, I don't know your version, but I click on this one. Oh, hold on a minute. I've just noticed something. I'll fix that right now. I didn't put the thing I wanted to show you in view. Okay, right. Are you back to seeing Canvas? Okay. Now, do you see the little guy at the bottom there that I now have made visible so you can see it? If you click on that, you'll get this video where this young lady, who's a pretty cool mathematician, goes over the major techniques that we've used. So it's another resource. If I click on this, you probably won't hear it. Yeah, actually it doesn't, but you will hear it in general. I think if you zoomed about here, yes, there we are. At the end of the video, she goes over this method that I'm showing you. And so I want you to kind of have, you know, maybe the way she'll say it will make more sense to you. I just want you to see another version of it, right? So that at least you've seen it twice, 2 different ways of saying it, whatever. And that's pretty much all I want to say about that. So I've got a little video and you can watch her. She also does difference of 2 squares and quadratics, right? So you can get a little bit more practice at seeing how she, how she says it. Okay, and that is that. So we need a joke, because if we are going to do some heavy duty math, and I've told you this is going to be a stinker of a method, we need a joke to get our brain relaxed and ready for it. And once we finish doing it, we'll need another joke to recover from it, right? So there are going to be some jokes floating around here, I hope. Has anybody got any jokes for me?
I do.
Go for it, Jimmy Lynn. What you got?
So why did the why did the golfer bring 2 pants?
I don't know. Why did the golfer bring 2 pants?
Because there might be a hole in one.
Oh, that joke once. Oh,
It's
that's
a good
cute.
joke.
It is a good joke. I'm not denying it. It's a good joke. Sean, have you got a joke for us? That's suitable.
What do you call a cow with no legs?
I don't know. What do you call a cow with no legs?
Ground beef.
Okay, that's good. Oh, yeah, you got someone who liked that a lot, right? Okay.
That's so loud for me.
Carla just thought that was that bad. It was good. Vanessa likes it too. So you've got a lot of praise on that one. It was so bad, it was good. Okay, what do you call a cow with 2 legs?
Stumpy?
No, lean beef. 2 legs, lean. Oh, okay. Okay, next one. Where would you find a dog with no legs? You can say no idea. Where
No
would you
idea.
find exactly where you left it?
These are really bad.
They are. I'm not denying it. They are really bad.
If we're talking
Bad.
about some missing legs, I think I have one made up in my head.
Okay, go for it.
So where would a one-legged worker work at?
I don't know where.
IHOP.
Oh, well done. That was creative.
You sure you thought about that?
Well, maybe she forgot that she heard it somewhere, because that happens. You know, you think it's unique and then you find out somebody told you, but you've forgotten that somebody told you. Right, well, we're doing the joke ones on this. There was a terrible, this is a Scottish joke, there was a terrible accident. This guy, he lost his left arm and his left leg. But he's all right now. Come on, it's bad, right? Okay. Oh, poor Madeline shaking her head. I didn't realize it was that bad. Okay. So next one is kind of sad, but it's Scottish humour, so we like macabre humour. What would you call a blind Bambi? And come on, you've got to do the bit where you say, I don't know.
I was thinking like roadkill, because like
No, it's
when
not
the
that.
deer go in front of the car.
No, it's not that, Jimmy Lynn. So, where would you find a blind Bambi?
I don't know.
Well, no idea.
Oh, that's kind of a stretch.
Bad.
Yeah. Okay. Where would you find a blind Bambi with 4 broken legs?
Oh, wouldn't it be like the taxidermy, like on the head of the wall? Or no?
No.
Oh,
That's dark.
My refrigerator?
No. God, you lot are killing this joke. Still no idea. I'm not using you lot as annoying.
I was gonna answer that.
With still no idea.
Yeah.
Okay. Oh God, like you're a lot just tough. Right. I do like Jamie Lynn's thought processes. It's kind of cool. Right. I think I've run out of Bambi jokes. Yeah.
I read one earlier.
Okay, go for it.
It's less of like a standard joke, but it was, dear math, I'm tired of trying to find your ex. Just accept that they're gone and move on. Because in math, you have to find the
A
ex.
math joke.
And my response to that is why?
Oh, a math reply joke. Oh, we are definitely dragging the bottom of the barrel now when we go there. God. Well, I don't know about you, but I feel pretty relaxed now. Okay, so let's get started. I guess I shouldn't threaten you, if that's the right word, threaten you, but worry you by saying something's absolutely horrible and a pain in the butt, right? Because this technique is quite intricate. But I think it's worth it to tell you that, because I want you to be under no illusions that when you look at this method and you say, God, that's hard to do, that you are in good company, because almost all of you at the beginning are going to be thinking, God, that's a hard method to learn how to do it, right? So it is what it is. So let me take the first question, which is, we are going to factor that guy. And let's try and show you where this came from. So it's called the magic cross method. You draw a cross, and the two outside numbers, you multiply them together, you get negative 24. And that guy there gets you 2. So 3 times 8, negative 24 goes in the top. Whatever that guy is, goes in the bottom. You don't need to know why they do that, you just do it, right? So it's a kind of, you follow the process, and it's like magic, right? Magic. At the end, you're going to get the answer, right? Are we cool with that as step 1? Agreed? Now, step 2, I'll use it red. We are going to find 2 numbers, and the 2 numbers have this property, which is kind of a property you've used before. I want 2 numbers that multiply together that give me negative 24, but when I add those 2 numbers together, I get 2. Doesn't that sound very familiar, right? So I'm looking for 2 numbers that multiply together that give me negative 24, but when I add those 2 numbers together, I get 2. And there's only going to be one combination that works for, right? So it's unique. Has anybody got the combination that works?
6 and negative 4.
Agreed. So we're going to go, oh, I'm in red, right? So we're going to go 6 and negative 4. Are we happy about that combination? Technically, negative 6 and 4 works as well, and that's fine. So I guess it's sort of almost unique. But are we comfortable about 2 numbers multiplied, negative 24, and when you add these 2 numbers, you get 2? So far, so good?
Where did the 2 come from again?
Came from here.
Okay.
Right. So the negative 24, you get that by multiplying these 2 together. And the 2, you just get it from that guy. Okay. Now that's step 2 over with. Step 3, I'm putting it in green here, try to do a color code. Now I'm just going to rewrite this guy. So I'm not doing anything except rewriting them. Now step 3 is really weird. You see these 2 numbers that you just found? Divide them by this number here. Divide them by 3. Why? Because I told you to, right? It's magic. You do that. Now, what does that leave me with? Well, it leaves me with a 2 over 1 and a negative 4/3. So step 4, simplify your fractions. We're almost finished with this weird method.
So the 3 comes from the 3x squared.
Yes. Now I'm going to do another question, and this guy is going to go here, and the second question is going to go here, and hopefully you'll say, oh yeah, you do that the same, you do this the same, because it's the same process. Right now it's kind of hard to say, well, that number's coming from there and this number's coming from there, but they always come from the same place, right? So the method doesn't change. Now, we are left with 2 weird looking fractions. These 2 fractions are actually going to give me the answer, right? It's going to give me these guys. So I wish I had more paper, so I'm going to just stick it down here. The final answer, step 5. You take this fraction, 2 over 1. And that guy, the bottom gives you 1x, and the top gets you plus 2. So that gets you the x, and that gets you the plus 2. Now, the second one I had was negative 4 over 3. The bottom gets me 3x, and the top gets me negative 4. We have now factored that guy. It's x add 2, 3x take away 4. Now, that's just the first one. The second one will probably be just as weird looking. But I think by the time I've done the third one, I'm hoping, you'll begin to see, okay, it's magic, but you do the same thing and it gets the answer. The answer are these two guys, right? The two factors that you get when you factor this up. Okay. So far, so good. You're just basically following, right? Not maybe 100% comfortable, but you're following. Let's put that guy here. And let's take the second one. So it's going to be 4x squared, add 2x. Oh, shoot and spice. Sorry. I didn't swear. I said shoot, like in a bullet, and spice, like in pepper. So I said shoot and spice. So our second question is, we are going to factor 4x squared, take away 7x, add 3. So let's start with our cross. Can you remember how you get the top number from here?
The 4 and times 3.
Yeah, so 4 times 3 is 12. How did we get the bottom number from this?
-7.
Are you comfortable about how I got those two numbers? Right? Do you notice it's the same way? The two guys at the outside gives you the top number, the guy in the middle gives you the bottom number. Okay. Now I'll change over to my pen here and do how I find these two numbers. So you're looking for two numbers that multiply together give you 12. Right? But when you add those two numbers together, you get -7. So it's pretty obvious that there are negative numbers involved. Would you agree? What two numbers multiply together give you 12, but when you add them, you get -7?
-4, -3.
Are you all happy about step 2 now? You see, it's the same as what we did last time, right? So step 3 is coming up in a minute. Now, in step 3, didn't we take these numbers and divide them by somebody, didn't we? And who did we divide them by?
It'll be the first number.
Which is basically step 3, great. And then you simplify. Well, there's not a lot of simplification here, but whatever can be simplified is. You notice that I don't bother writing these numbers down here and here now because I don't want them, they're distraction. Aren't these the two guys that are important for getting the answer? Right, these two weird looking things. Now, won't each one of these give me one of my factors? So this is step 5 now. -1 over 1. And the other one's going to be -3 over 4. The guy in the bottom tells me how many x's, in this case 1x. The guy in the top tells me what number. The guy in the bottom tells me how many X's I've got. The guy on the top tells me my number. I now have my two factors. Was it a little less weird the second time compared to the first time? Right, it's total magic. There's no rhyme or reason for why all this jiggery-pokery works, but it does work, and it's probably the only procedural way you'll ever be able to factor these, apart from just guess and check. I guess you could solve it that way. Couldn't you just keep trying till you found one that worked? But can you imagine how long that might take you if you tried just guessing all the time? You'd get really frustrated if it was a really big question and it took you 12 guesses before you got it. At least in this method, don't you get the answer at the end every time? Okay, so that's the second one done. I'll keep that one there. And this is our next one. 5x squared plus x take away 22. Now, although you're not going to get a lot of homework questions in the radical homework, this process is going to come back again towards the end when we sketch quadratic curves. So you're going to be using this again in the future, right? So it's going to do double duty. It's going to help you simplify rational functions. You won't get too many questions where you do that, but it will help you for those that you do. And then later on, it's going to help you when we do quadratics. So step one, what number goes on the top?
110.
Yeah. And on the bottom, 1. Now, that might seem like a big, tall order here, but actually I don't think it's that difficult. There are two numbers out there that multiply together and give you negative 110, but when you add them together, you get 1. They're actually quite easy numbers if you think about it. Have you got them yet? Negative 110. Two guys get you negative 110. And when you add them, you get 1. No one got it yet?
11 and 10.
Yeah. Which one of them's negative?
The 10 is negative.
Ah, your great works now, right? Now, suppose you couldn't see 110, right? I don't know what works. Side issue, how do you find the answer to the puzzle? Two numbers multiply, give you that. It's not very nice, but it works. You take negative 110, right? And you split it by calling it 2 times 55. Would you agree that's never going to work? You try 3, but 3 doesn't work anyway, right? And then you try 4, which doesn't work. Then you try 5, and you get 5 and 22, and that doesn't work. And you try 6, but 6 doesn't come out even. 7, 8, 9 doesn't come out even. Then you try 10, and 10 and 11 comes out, and you say, ah, gotcha. So you grab a calculator, and you just go through anything that divides 110, make that your first number, and then what's left is your second number. And then you look at them and say, nah, you're never going to get 1 out of that combination. Nah, never going to get 1 out of that. Yep, that's the one. And normally there's not like an infinite number of combinations up here, right? There's probably only 4 or 5 at most. Are you a little bit more comfortable where that came from? Right, back to the puzzle, back to this fella, because we've only done step 2. Step 3, I'm going to divide these guys by somebody, right? What number will I divide these guys by?
No.
Right, great. And then simplify. That one can't really simplify it. This one, we got it. And now we're ready for the answer, aren't we? Because step 5 is coming up. each one of these fractions is going to give me one of these two factors. So let's see, we have 11 and 5. Okay, 11 on the top, 5 in the bottom. Which one of these numbers tells me how many x's I'm going to have?
5x.
Great. And what does the 11 tell me?
Plus
Maybe it's a bit,
7.
yeah, it's probably just the way I phrased it. Isn't the 11 just the number, right? Okay, the second one, -2/1, right? That's this one. How many x's do you get from this fella?
1x minus 2.
And we have now figured out how to factor the ugliest quadratics in the world. It doesn't matter how ugly these are. This technique will get you out of a hole, right? And that's what it is. Do you feel ready to do one of your own? Because that's how you're going to tell if you've got it, right? If I give you one to do on your own. So give me a minute and I'll figure one out. I don't know how long to give you. When you think you've got the answer, if you stick a little thumbs up, once half of you have got the answer, I'll call it good, okay? So, factor that guy. Using the magic cross method. Oh, God in Himmel. I have given you the ugliest looking question in the world. I've just realized it. Oh, God, that's a horrible question. I apologize. But treat it as a challenge. You would never get one as ugly as that in the test. I would never do that to you. But treat it as a challenge. If you can do that one, there's not a quadratic in the world you can't do. God, that's ugly. You need your calculator for this one. Whew. I finally found one that worked. It is doable. to try and give some other people a chance to finish this question, has anybody found the two numbers that work?
I have.
Okay, tell me what they are.
So it'll be a negative 14 with a 17.
You got it. That's what I have.
I just started putting random numbers and
Yeah,
trying to get close.
That's all I was doing. I was just keep hitting until I got two that worked. But you know, at least the calculator speeds that bit up, right? And I did say if you can do this one, you can do any. So
Would it matter if I did a negative 17 and a positive 14?
it would change this because that wouldn't add up to +3. So your sign would be a little bit out because of that.
Oh,
You know that these two have to add up to +3, and this order works. But if you switch the negatives, it adds up to -3 and it doesn't work. Your answer would be very close to being right, but the signs would be in the wrong place. Have we got anybody finished yet? Oh, yeah.
And I have a question. So once you find the answer and you put them in the parentheses up there,
Yeah.
like would it matter which one goes where, or?
No.
Okay.
So 2x plus 3, x minus 7, x minus 7, 2x plus 3, don't matter. So does that mean you've got yours, Jamie?
Yeah.
Right, that's two people I know. Anybody else? I guess I should go on the big screen and just see if there's some more thumbs ups. We got anybody else finished? Whoa, there we go. We got 3 now. Let's go for a couple more. Oh, good. We got it. We got half. I compliment you on your perseverance for what shouldn't have been as hard a question as I thought it was going to be. But it's good because it means you know how to do it. So 7 times -34 is -238. And where the heck did that come from? Yeah, glad I caught that. There's a 3 in the bottom. So the combination that worked is this. We're then going to divide this guy by 7 and this guy by 7. And then simplify. So what's that? -2/1, and you can't really simplify that. So -2/1 gets me 1x, take away 2, and 17/7 gets me 7x plus 17, and we have an x minus 2 and a 7x add 17. You get that? Are we good? Whew. That was a question and a half. Okay, let me, oops, see if I can get back into, oh God, it's being weird, my computer. Right, let me show you, we're almost finished this section, so let me show you a question where you needed to do this, the magic cross method. Boom, 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 boom. Don't want that. Don't want that. No, no. Check this. Okay. A version of 11. So 2n squared, take away 9n plus 4. And on the bottom, it's going to be 2n squared, take away 6n minus 8. And I do know that these are all going to factor, so that's what's going to eventually happen. Let's just move this over here because there's a fair amount of working on this question. So let's just focus on factoring that guy, all right? Now, quick sketch. scan. Would you agree there is no common factor, right? I can't pull out a 2 or anything. So I'm going to go with the magic cross. 2 times 4 is 8, and that number is -9, right? 2 times 4 gets you 8, and the middle number is -9. So what I'm now looking for are 2 numbers that multiply together give me 8, but when I combine them, when I add them, I get -9. Would you agree that -1 and -8 is the combination that works? Now, what do I divide these 2 numbers by? Because that's the next step. What number do I divide these 2 numbers by?
2.
A 2, right? This guy here. Which means that I now have -1/2 and 4/1. Great. -1/2, 4/1. Right, we're ready for the answers then. -1/2, the 2 gets me 2x minus 1. And the 4/1, that gets me an x and an add 4. And so 2x take away 1, x add 4. Right, that's a normal kind of version of that, right? It wasn't that really ugly one I gave you, right, with the 34 now. I mean, isn't that reasonable numbers that you can work with without too much trouble? So the top is 2x minus 1, x add 4. I'm happy with that. Are you happy with that? Okay, now, you might be tempted to do this question. Oh, yes.
So why is it, hold on, where'd it go? X plus 4 instead of x minus 4?
And the answer to that question is...
Or 1, or sorry, so 1 minus 4. Or, yeah, x4.
Yeah. The answer to that question is it's late on in the day and I screwed up. Because it should have been -4. And thank you for catching it, because I didn't. Right, so next fella is this guy. Now, this guy could be done using the magic cross method, but it's a good idea not to. Do you notice that there's a common factor here? Right, what common factor can I suck out of this?
2.
2. Now, when I do that, would you agree that we get a much easier to factor guy? And I won't, isn't that just a normal, simple quadratic? So let's see what we get. 2 numbers that multiply together that give me -4. And when you add them, you get -3. So I believe that is -4 add 1. Would you agree? Now, what we got? 2 lots of, oh, shooting space. I apologize. I am getting really, really tired, I think. The top guy was n's, not x's. Fix that. And the bottom guy is n. Right, so after who knows how many mistakes, we finally got to here. Can we cancel anybody? Can we simplify? Is there somebody in the top that can cancel out somebody in the bottom?
N minus 4.
And that leaves me with a 2n minus 1 on the top and a 2 lots of n plus 1 on the bottom. And we solved our question. I think there's only 2 questions in the homework that you will need to use the magic cross method, right? There are only 2 situations. There might be 3, I might have missed one, but there are only 2 that I believe, and that's one of them, right? So you're not going to do that quite as much as all the other techniques, but for the few times that you need it, it's probably the best and only way to do it. Any questions about that? Do we need a joke to finish? We do. Has anybody got one? Because my brain is about sponge right now. So there ain't a lot coming out of it. Okay, what shall we think of? How many French people does it take to defend Paris?
You know, I have like a German version. I just thought of that. It's like the
Okay,
same one. If you say like how many German people does it take to protect like Germany? I think the German word of it would be like 9 or something.
Oh,
I don't know if that's German or not.
I
but,
don't
like,
know that one. Okay, I'll get this one over with. So you're meant to say, I don't know. So ready? Here goes. How many Frenchmen does it take to defend Paris?
I don't know.
I don't know.
Nobody does. It's never happened yet. Okay, Rachel got that joke. The rest, that joke died a very bad death. Okay. Oh, Vanessa has just came in. We have done an awful lot of work today, and I think we probably, based on the fact that my brain is turning to sponge, and I don't feel I want to do too much. I have a couple of things I want to do, but after that, we'll just call it quits. I think it's probably a natural point. So I'm going to show a couple of little tidying up things in this, and then I want to show you what's expected of you this Sunday, right? What I expect to see from you, and then we'll call it a day. So I want you to imagine that we did one of these cancelling situations, and you had an x minus 4, an x plus 1, and you had 2 lots of x minus 4 on the bottom. So imagine that's what it factored out as. Nothing special going on. You cancel these two guys, and the answer is x plus 1 over 2, and you would be correct. Great, nothing special. But what happens if you had an x minus 4 over x plus 1, and all that was on the bottom was x minus 4? Well, you cancel them out and you leave behind a 1. And a lot of people would think, well, the answer is x plus 1 over 1. But that's actually not how you write that. That's a very special case. How do you think you should write x plus 1 over 1?
X plus 1 over x.
Would
But
it just be x plus 1?
Exactly. If I said to you 7 over 1, wouldn't you just say, well, why are you writing it like that? It's 7.
I just realized my brain is also toasted.
Yeah, I totally agree with you. I think, yeah, 2.5 hours is probably a little bit too much for everyone, including me. But we're comfortable with what that does, right? So I'm just saying that because the way that WebAssign does questions, doesn't it randomly assign numbers to things? And so that your question 17 is not Rachel's question 17, right? And I can guarantee that when you do that, isn't there going to be a situation where this might happen? And so you're going to plug that into WebAssign and it's going to say wrong. And you're going to be pulling your hair out because you didn't realize you could do that. Now, I'm going to do another question that looks very similar, but is not that answer. I'm going to put the x minus 4 on the top, and I'm going to do the x minus 4 over x plus 1 on the bottom. Right? Now, you notice I put them in the opposite position. Now, you can cancel. When you cancel, you leave behind 1. But do you see in this case, the 1 is important? Because isn't the answer it is a fraction, isn't it? It's 1 on the top and x plus 1 on the bottom. Do you see in this case, it's not really a fraction anymore because of the 1. But in this case, it's still a fraction. So when you cancel things out, it is important that you're aware of when you can do this and when you're not allowed to do this. Are we good? Right, now the next couple of things are to do with WebAssign and then Canvas. So let me get myself set up for that. Put this over here, and I'll zoom over and show you the WebAssign issues. Right, if you're looking at WebAssign, whoops, do you notice that there are a couple of questions where you watch a video? So I expect you to watch the video, and once you've watched the video, it'll ask you to do a little simplification, and one of these is the right answer. And I believe there's another, yeah, there they are. And there's another video where you're going to simplify that, and when you're finished, the answer is going to go in here. And I just noticed something. When you click on that, do you notice the little math pad thing appears so that you can put in fractions? And I'm making this up, but you can type in 2x minus 5 and then go down to the bottom and do x minus 7. Do you see that's how you get your fractional expressions into your WebAssign answers, right? When you click on the box, this little palette will appear, and there's the guy that you use to do fractions, right? Have you all probably noticed that anyway in other homework questions, that that's what you did, right? So that's that out of the way. So I don't want to talk any more about that. I don't know. Can you see Math 99 right now? You can. Okay, good. Let me see if I can put it onto student view. That might make it a little bit clearer. I don't want to join your upcoming webinars. They tell me things we don't want to do. Now, the following is a suggestion, not an instruction. You can choose to do homework 6, rational functions, this week. I strongly suggest, but it's only suggesting, that you do that. You must, however, get these guys finished. So this Sunday, by midnight, you have to have finished linear equations. If you've got time, I strongly suggest you do this, because if you don't do it this Sunday, won't it be 2 weeks from now that it'll be due, and you might not do it and you'll forget how half the things, especially the cross method. So while it's fresh in your brain. Secondly, if you do, and it's only a suggestion, if you do it, won't you have less work to do in the next 2 week period? So it will help you get the answers. I don't want to make it mandatory, because it wasn't on the syllabus that it was going to be due this 2 weeks, and I don't want to move the goalposts on you and suddenly say, well, I prepared to do 6 homeworks, but now you've told me it's 7. That's kind of unfair. I wasn't ready for it, right? So that's why I'm not making it mandatory, but hopefully you're working a way through that. So everybody here should be in WebAssign, already joined up. Even if you're using the 2 week free period, that's fine. But you got to get it done, and you have to get the first 5 homeworks, and that's mandatory, right? You got to get it done. Well, I guess mandatory somewhere. But if you don't get it done, I'm not giving you the points, right? So that's maybe something you have to be aware of.
Where would you go to put in the code for when the trial week ends?
Well, once your trial period ends, they will send you an email saying, hey, you better pay. And when you go to the week, you better pay. Have you already got the card with the code in it?
Yeah, I do.
Right. All you need to do then is type in that code when they tell you time's up. Right. Okay. And I'm don't quote me this, but I believe that's what happened. Now, if it doesn't happen, you know that they've got you can phone them and just contact them and say, look, I've got my code. Can you do it for me? If it's not working for you.
Okay.
Okay. And the last thing I want you to do is, if I can make this happen, right, is just, that's not the page I want. Excuse me. I've lost it. Okay. Where the heck is, oh, that's Zoom. Come on. I know you can do it. Right, and here is Math 99. And that's good. There's student view. Are you looking at Canvas page right now or not? You are good. I'll probably make it just a little bit bigger. Won't take more than a few moments, and that'll be us for today. I haven't been getting really that many people from this class doing officer, and that might simply be I'm working, and I understand that, and you can't do it. But if you do have questions, you can at least shoot me an email, right? And I can try and answer it that way. Or you can come a little bit earlier, or you can hang about at the end of the day, right? And I'll go over some homework questions and fix it for you. Because the worst thing you can do is just let it simmer. Because I can't do question 5 and I'm stuck in question 6 and now I can't do any of it, and you get all frustrated. So if we can fix it, you can then get back to doing the rest of the questions.
I had a question about the assignments.
Yes.
Can we open them up so that there's more available? Like if we like,
like I did with the rational function one.
Yeah.
So you just want to work ahead a little bit?
I do.
Yeah, I can do that, but it takes a bit of time. So could you wait until the weekend when I have time, and I'll try. But here's another thing to do for me. I'm old and I forget things very quickly. So if you shoot me a little email saying, remember, could we get some more sections, and I will do it. But basically I have to go in and make them up and put them up, and it just takes time. It's not that I can't do it. It's not a big deal, right? So we are good with that. What else I want to talk about? Oh, there's my little video. If you click on this one, just showing you some resources that you may not be aware of. So what I have here are some notes on factoring, right? So some people like watching videos and some people like to see it written down, right? It's just a resource and it's there for you. And that's us for today. So will you say hi and bye-bye? And anybody who wants to hang about because they've got some homework questions or whatever, I'm going to be here for you, and you can just ask me what you want.
I just have a quick question. I'm sure you've explained it. It might have just gone past me. But when we're doing the magic cross method,
yes,
how do we know we're doing that versus just factoring?
Okay. I'm going to jump back to my whiteboard to write down what it looks like. When you have guys, right, quadratics, and that is a number, then you're going to do the magic cross method. With one exception. If you can pull it out as a common factor, I suggest you do it common factor and then the old-fashioned way. But if that's 2, 3, 5, 7, anything like that, that's how you would do it.
Okay, thank you. That makes sense.
Okay.